Hello and welcome to our Problems of the Week, Week 15. We're looking at Monday through Wednesday today. Our theme this week is City Bus. Alright, so let's take a look at Monday. Victor's class is going on a field trip. They will ride the city bus twice, once going and once coming back. The one-way bus trip costs 35 cents per child and 50 cents per adult. There are 24 students, 4 parents, and 1 teacher going on the trip. How much money will they need for everyone to ride the bus? Whew, holy cow, we got a lot of math going on in here, so you know I'm excited about this one. Alright, so let's start with the first piece of information. They're going to ride the bus twice. They're going to go, and then, guess what? They're going to need to come back, right? We call this a round trip. That's another way to talk about this. So we start from point A, and then we go to B, but then we have to go back, right? Because that makes sense. Now, that's important to note because if you look at the next piece of information, the cost that they're giving you for kids and adults is one way. So, boys and girls, I need to pay to get to where I'm going, but guess what? I got to pay to go back. So keep that in mind as we're calculating how much this is going to be. All right, so that's important to know. Round trip, go there, come back. Very important. All right, so the next thing I need to be aware is that there's different costs for children than there are adults, okay? So I need to know exactly how many kids are going, how many adults are going. So according to my problem, when I go back, I see that I have 24 students. So children, I've got 24 kids going. Now, the next piece of information is the adults. How many adults, right? Well, 4 parents and 1 teacher. Yes, sad but true, we do consider ourselves adults. So, how many adults total am I going to pay for? Think about it. Think about it. 4 parents, 1 teacher. I hope you got it. I'm going to be paying for 5 adults. Okay? All right, good. So I know how many kids, I know how many adults. Let's find the cost of 1 trip. I know I'm coming back. I know I'm going to need to double that. But until I know the cost of 1 trip, I won't know the amount to double. So let's go back and let's figure out how much for kids, how much for adults. Now there's a kind of an important word here. Per. Ooh, fancy word. The word per means like each, right? So I have some options here. It says that it costs 35 cents for each child, per child. So I've got 24 kids, so if you'd like to, you could take 35 cents and you could add that 24 times. Be my guest if you want to. Feel free. I prefer to find a more efficient way to do that. What is the same as repeated addition? Think about it. Think about it. Hopefully you realized that repeated addition, or you remembered, repeated addition is the same as multiplication. You got it. So wouldn't that be faster? I think so. So I'm going to take those 24 kids and I'm going to multiply it by my 35 cents. Hope you see my decimal there. You see my decimal? Okay. And that will give me the cost for my children for 1 trip. 1 trip. Remember? We're only going there for this cost. Okay, so now for my adults, so we said 35 per child. My adult cost, going back, was 50 cents. So, again, I could take that 50 cents and I could add that 5 times. 5 is a little more reasonable than 24. But, more efficiently, I could take that and multiply that 50 cents by 5. Okay? So now, once you've calculated the cost for all the children and the cost for all the adults, how much is it for everybody? Okay? Now, just when you think you've done enough math for one day, we're not done, people. We're not done. That's only for one way. One way. So what am I going to need to do to this total? Because because it's not my answer, I am going to have to use that number twice. I'm going to leave you there. Think about it. But this total is not your answer. I need to do one more step with that. Think it over. Okay, let's take a look at Tuesday for week 15. Mrs. Kula's class was going on a bus trip. They left school at 9:30 a.m. The bus trip to the zoo took 1 hour, 15 minutes. They stayed at the zoo for 3 hours and then went back to the park for 50 minutes before boarding the bus to return to school. So, at what time did they board the buses? Okay. So I've got a lot of time increments here. I've got a sort of like the time they left school and then some little activities here and there they did throughout the day. And what I'm thinking that they, when they mean board the buses, I assume they mean to go back to school. So I need a strategy here for time. There's a couple of different ways you could deal with time. You could have like sort of like a list, and add up the time that way. That's not a bad way, but I've kind of fallen in favor of using sort of like a big number line to kind of like be more of a visual. So if you'd like to join me on that adventure, feel free. Here's my big number line. Notice it's really big kind of across the whole problem here. And I'm going to go ahead and start with my starting time when they left the school. So over here, I'm going to go ahead and put 9:30 a.m. That's kind of important because I have a feeling our boarding the bus time is going to be a p.m. time. And then I kind of like to go hours and then minute chunks. So let's see. Started at 9:30, took 1 hour and 15 minutes. So one hash mark is an hour. So I know then that time is going to be 10:30. And now let's make another mark for my 15 minutes. So you got to know about your time. If it's 10:30, 15 minutes later would be 10:45. Okay. So I've accounted for my 1 hour and 15 minutes, so I'm going to kind of cross those off. They stayed at the zoo for 3 hours and then went to the park for 50 minutes. Okay, so I got a nice chunk of time for 3 hours. So I'm going to make 1, 2, 3 marks for those hours, and let's make those jumps. So if it's 10:45, 1 hour would make it 11:45. This is kind of sloppy. 11:45. Another hour would be 12:45, and another hour would be 1:45. All right. So I'm done with my 3 hours. I'm going to cross that out. Kind of helps me keep organized. Then they went to the park for 50 minutes before boarding the buses. So now my last jump is just going to be those 50 minutes. So from 1:45, that 50 minutes, and that should give me the time they boarded that bus back. All right? So I know I'm at 1:45 now. Think about what that 50 minutes would be. So remember, you may want to actually look at a analog clock. That might help you kind of figure out those 5-minute increments. And you could even count by 5 minutes and make those hash marks on that number line, or chunk it by 10 minutes. There's a lot of different ways to do it. So take 1:45, add that 50 minutes, and that should be the time they boarded the bus. Don't forget, is it AM or PM? Don't forget to include that in your answer. All right, so here we are on to Wednesday. The city bus is 45 feet long and 10 feet wide. The maintenance crew wants to paint 2 yellow stripes around the outside of the bus. So what will be the total length of the 2 yellow stripes? Okay, 45 feet long and 10 wide. You know what that reminds me of? That reminds me of a rectangle. Look at me drawing a diagram. Look at me applying those strategies. All right, so if it's 45 feet long on this side, what do I know about the opposite side? Yeah, you're right. It's 45 feet long. And if it's 10 feet wide on one side, what do we know about the other side? Ugh, can't get anything past you guys. You're right, it's 10. Sorry, that's so sloppy. Okay, 10. All right, so let's go back. So we have 45 feet long, 10 feet wide, and I want 2 yellow stripes around the outside of the bus. Stripe 1, stripe 2. So what's going to be my total length? Good luck, guys.